Hello learners, welcome to all of you in this video lecture. Myself Dr. Narendra Kumar Singh, Associate Professor, School of Pharmacy, Babu Banarsi Das University, Lucknow. Today the topic of our discussion is limit test of iron. We know that limit test is a quantitative or semi-quantitative test performed to identify a very small amount of impurities present in pharmaceutical substances. So any pharmaceutical substances, whether it is active pharmaceutical ingredient or excipients, it must pass the limit test of chloride. So if the quantity of iron present in active pharmaceutical ingredient or excipients is less as it is prescribed in different pharmacopoeia, then only it is used for the formulation of any pharmaceutical product. So the limit test of iron is based on the principle that iron in ammonical solution react with thioglycolic acid and form a complex iron thioglycolate. The color of iron thioglycolate is red or purple. So intensity of thioglycolate compared with the standard iron solution, if the intensity of color of iron thioglycolate in the test sample is less as compared to the intensity of thioglycolate in standard, then the sample passes the limit test of chloride, and then only it can be used for the formulation of any pharmaceutical product. So coming on the reaction on which the principle of limit test of iron is based. So when ferric form of iron react with thioglycolic acid, then ferric form of iron is converted into ferrous form. The ferrous form of iron, it react with thioglycolic acid and a complex is formed this complex is formed, and the color of this complex is red to purple. So intensity of the color of this iron thioglycolate produced in test sample is compared with the intensity of iron thioglycolate in the standard. If the intensity of color of iron thioglycolate in the test sample is less as compared to the intensity of color of iron thioglycolate in the standard, then our sample passes the limit test of iron. So this is the basic principle behind the limit test of iron. Now coming on the procedure for the limit test of iron. So for the limit test of iron, we have to take two Nessler cylinder, one for test sample and another for standard. So here we have to use two Nessler cylinder of 50 ml capacity, one for test and another for standard. So one Nessler cylinder for test sample and another Nessler cylinder for standard. Both Nessler cylinder used here of 50 ml capacity. So in the test Nessler cylinder, we have to add a specified quantity of sample dissolved in water, or as it is prescribed for a particular substance in pharmacopoeia. So a specified quantity of the sample is taken in test Nessler cylinder, and then we have to add 2 ml of 20% WIV solution of iron free citric acid, solution, and 1 ml of thioglycolic acid. Then the volume of content in test Nessler cylinder is maintained up to 50 ml with distilled water. So the iron present in test sample, it is react with thioglycolic acid in presence of ammonia solution. Ammonia solution is added in the limit test of iron to maintain the basic environment, and iron react with thioglycolic acid in presence of ammonia. In standard Nessler cylinder, we have to use 2 ml of standard iron solution, and its strength is 20 ppm. I will tell you later how can we prepare the 20 ppm of standard solution of iron. So 2 ml of standard iron solution is taken in standard Nessler cylinder, and similarly it is added with 2 ml of iron free citric acid solution. The strength of this citric acid solution is 20% WIV, as I have told in case of test solution, and then 1 ml of thioglycolic acid is also added. Then solution made alkaline by using ammonia solution. Finally, the volume of standard Nessler cylinder is maintained up to 50 ml with distilled water. So in this manner, the color produced in test Nassler cylinder is compared with the color of iron thioglycolic acid produced in standard Nassler cylinder. If the color intensity of iron thioglycolate in the test Nassler cylinder is less as compared to the color intensity of iron thioglycolate in the standard Nassler cylinder, then our sample passes the limit test of limit test of iron. But in case if the intensity of color in standard Nassler cylinder is less as compared to the color intensity in the test Nassler cylinder, then our sample failed the limit test of chloride. So this is the procedure for the limit test of iron. Now coming on the preparation of standard iron solution used in the limit test of iron and preparation of citric acid as well as sulfuric acid used in the preparation of standard solution of iron. So 20 ppm standard iron solution is prepared by diluting 1 volume of 0.1726% WIV solution of ferric ammonium sulfate in 0.05 molar S2SO4 to 10 volume with water. So standard iron solution 20 ppm can be prepared by diluting 1 volume of 0.1726% WIV solution of ferric ammonium sulfate in 0.05 molar H2SO4, and this 1 volume of ferric ammonium sulfate solution is diluted up to 10 volume with water. The molarity of H2SO4 solution used here is 0.05 molar. So this 0.05 molar H2SO4 solution can be prepared by diluting 54 into 0.05 ml of concentrate H2SO4 to 1000 ml with water. So this much quantity of concentrated H2SO4, first it is diluted with 10 to 50 ml of water, and then finally the volume of H2SO4 is make up to 1000 ml with water. This is the procedure for the preparation of 0.05 molar H2SO4, and this 0.05 molar H2SO4 solution is used in the preparation of standard iron solution 20 ppm with the help of ferric ammonium sulfate. The citric acid solution that is used in the limit test of iron is 20%. This 20% iron-free citric acid is prepared by dissolving 20 gram of iron-free citric acid in water, and volume is made up to 20 ml with water. So this is the procedure for preparation of standard iron solution and other reagent used in the limit test of iron. Now coming on the limit test of arsenic. Limit test of arsenic is based on the principle that when zinc react with hydrochloric acid in presence of stannous chloride, hydrogen gas evolved in this reaction. This hydrogen gas produced by this reaction of zinc and HCl, it react with arsenic in the sample and it convert the arsenic in form of ASH3, that is called the arsine. This arsine gas developed by the reaction of hydrogen and arsenic present in the sample, it react with mercury chloride and it form a yellow color complex. So the color of this yellow stain is compared with the standard stain that is developed by taking a standard solution of arsenic. So if the intensity of yellow color stain in the test sample is less as compared to the yellow color stain that develop in the with the standard solution of arsenic, then our test passes the limit test of chloride. And in case where the intensity of yellow color in test sample is more as compared to the intensity of color in the standard sample, in that case our test sample fails the limit test of chloride. So test sample fails the limit test of arsenic. This is the basic principle behind the limit test of arsenic. A special apparatus used in the limit test of arsenic, that is called Gudgite apparatus. This Gudgite apparatus consists of a conical flask or a glass bottle of capacity 100 ml, a tube of 20 centimeter, that we can say that 200 millimeter is inserted inside this conical flask with the help of a cork. The lower end of this tube have a pore of 1 mm diameter and a side pore of 3 mm in diameter, that is few centimeter above to the lower end. Another tube of diameter 5 mm. The diameter of this tube is actually 5 mm. So a tube of similar diameter of 5 mm and length 30 mm is placed above this tube with the help of a cork and a clamp. A paper of 15 mm by 15 mm, which is impregnated with mercury chloride, is placed between these two tubes in such a manner that the center of this paper is placed above this tube and below this tube. It means this paper, which is impregnated with mercury chloride, is placed between these two tubes with the help of a set of two cork and clamp. The upper end of this tube is filled with a cotton plug of 50 to 60 mg in weight, which is moist with lead acetate. So this is the description of gadget apparatus used in the limit test of arsenic. A set of two gadget apparatus is used, one for test sample and another for standard one. So in this manner, the color produced in this mercury chloride paper, which is placed between these two tubes, is compared with the standard. If the stain, yellow color stain on this paper in the test sample is more intense as compared to the stain developed in the paper which is used in the standard gadget apparatus, then our test sample fails the limit test of arsenic. Otherwise, if the stain in the test gadget apparatus is less intense as compared to the intensity of stain in the standard gadget apparatus, then our sample passes the limit test of arsenic. So this conical flask is of 100 ml capacity. In this conical flask, we have to add 5 ml of 1 molar potassium iodide solution and 10 gram of zinc AST. AST means zinc which has no any trace of arsenic, means zinc which is free of any trace of arsenic. After adding potassium iodide and zinc AST in this conical flask, this assembly is set as per their as per the guideline that is mentioned in pharmacopoeia, and it is placed on the water bath at a temperature such that the gas evolved should be uniform in both test and standard gadget apparatus. So after 40 minutes, the stain developed in both the gadget apparatus is compared on this mercury chloride paper, and if the intensity of stain in the test paper is less as compared to the intensity of the stain developed on the standard mercury chloride paper, then our test sample passes the limit test of arsenic. So this is the basic principle behind the limit test of arsenic. When zinc react with HCl, it produces hydrogen gas. This hydrogen gas convert the arsenic present in the sample in form of AsH3, that is arsenic gas, and this arsenic gas reaches through this tube to the mercury chloride paper, and it reacts with the mercury chloride and it forms a complex of yellow color, and therefore develop a yellow color stain on the mercury chloride. Now coming on the preparation of standard arsenic solution 10 ppm. So standard arsenic solution of strength 10 ppm, 10 parts per million, is prepared by dissolving 0.330 gram of arsenic trioxide in 5 ml of 2 molar sodium hydroxide solution, and the volume of this solution is make up to 250 ml with water. One volume of this solution is taken and the volume of this solution is diluted up to 100 volume with water. So this is the procedure for the preparation of 10 ppm standard arsenic solution. Thank you so much.